Hello, my name is Jason Spangler, and I'm the Chief Executive Officer at the Innovation and Value Initiative. We are so pleased that you're here today and can share in this learning laboratory for IVI. We also want to thank the many people who have been such incredible partners since the beginning of this initiative. That includes IVI members and board of directors, multi-stakeholder advisory group, our technical expert panel and clinical expert panel, our research partners, including people from Medicus, Open Health, EvaViz, Carelon, and the PAVE Center at the University of Maryland School of Pharmacy. Also want to thank the IVI team, both current and former team members. This has truly been a team effort. As you know, the Innovation and Value Initiative's mission is to advance the science, practice, and use of patient-centered health technology assessment to support decisions that make healthcare more meaningful and equitable. We chose major depressive disorder as our next economic model because of the devastating personal and economic impacts of MDD. Almost every person in this country has been touched by depression in some way. The COVID pandemic and the last few years have only underscored this reality. MDD leads not just to human suffering, but also to significant economic impacts. It is estimated that major depressive disorder leads to over $210 billion in annual costs. The IVI-MDD Value Model is a tool for researchers, purchasers, patients, and other decision makers to make more informed decisions about treating MDD. In addition, we see the IVI-MDD Value Model as a way to explore different approaches to health technology assessment and to offer a tool that you can use to test methods and questions that are important to you. As you know, we're holding a public comment period on the beta version of the MDD model from now until Friday, December 15th. We will then review the comments and work with our advisory committees to prioritize which updates we can do now and which ones we will do later. Today's webinar will be broken into two parts. In the first hour of the meeting, we will provide a brief overview of the purpose and goals of the model and provide a demonstration of the model and types of research questions you can explore. We will also have time for questions. In the last 30 minutes, we will take a deeper dive into some of the thornier technical questions that we are exploring and give you a chance to ask more detailed modeling questions of our team. Please put all questions in the Q&A. Our research team will be able to answer questions in the chat as well. Now, I'm going to turn it over to Erica Defer-Malik, our Chief Operating Officer, who's going to speak briefly about the purpose and goals of the model. Thank you.
So my name is Erica Defer-Malik. I am the Chief Operating Officer here at the Innovation and Value Initiative. And we are so pleased to see so many of you guys here today. I'm going to share my screen and make sure that you can see our presentation. They said this is an introduction to IVI's value model on major depressive disorder, and it's an informational webinar and a demonstration. I wanted to start by thanking every single person here for attending today and learning about our event. I wanted to also thank all the many partners that we had in developing this model, including IVI members, the MDD Multi-Stakeholder Advisory Group, our technical expert panel, our clinician expert panel, IVI members in the board of directors, and our IVI partners, Medicus, Open Health, EvaViz, the University of Maryland PAVE Center, and I can't read my writing, but and Carelon. And most importantly, I want to thank the IVI team, both past and present team members. So thanks to all of you. Oh, and we do not have subtitles right now. Today's webinar, we're going to be talking, the purpose of this webinar today is to be able to share information about the background and purpose of the webinar, areas for which IVI is seeking input and a demonstration of the model. The second last half hour of this webinar will allow for you to ask questions about the more technical aspects of the model. As you know, the Innovation and Value Initiative's mission is to advance the science, practice, and use of patient-centered health technology assessment to support decisions that make healthcare more equitable and meaningful. We chose major depressive disorder as our next economic model because of the devastating effects and personal and economic impacts of MDD. Almost every person in this country has been touched by depression in some way. The COVID pandemic and the last few years has only underscored this reality. MDD leads not just to human suffering, but also to significant economic impacts. It is estimated that major depression disorder leads to over $210 billion in annual costs. The IVI-MDD Value Model is a tool for researchers, purchasers, and patients, and other decision makers to make more informed decisions about treating MDD. We see the MDD model as a way to explore different approaches to healthcare technology assessment and to offer a tool that you can use to test methods and questions that are important to you. As you know, we are holding our first public comment period, our third public comment period on the model right now, and will be open until Friday, December 15th. We will review the comments and work with our advisory committees to prioritize which updates we can do now and which ones we will do later. Today's webinar will be broken into two parts. The first part will be an introduction and a demonstration, and the second part will be where you can ask more technical questions. I would like to please encourage you to put all your questions and comments in the Q&A. If there's a term or a language that's being used that you don't understand, our colleague Michelle will be including those definitions in the chat. I also wanted to spend a brief moment just talking about the background of this model. As we had said, this model was really picked because of the devastating effects of MDD, but we also wanted to use it as a way to test new methods. Some of the key things that we did differently this time versus last time is that we established a multi-stakeholder advisory committee from the outset to help us develop our research questions and develop how we are going to approach the MDD model. We included both. We also included both pharmaceutical and non-pharmaceutical treatments in the model and make sure that we kind of are looking at how does accounting for other treatments and types of treatment impact the cost effectiveness. I also do want to note from the outset, and I know Rick will notice this as well, that the lack of data is a pervasive challenge in health technology assessment, and that MDD is an important demonstration of how HTA cannot be used in a vacuum. I wanted to just finally highlight 3 ways that our advisors and partners have influenced the development and approach that we had to the model. The first was that when we initially started this model, we were only going to address treatment-resistant depression. But our advisors pointed out that the complexity of this label, it makes it so that that is very difficult to assess. And so we have focused more broadly on MDD. We have also wanted to highlight that the reality that many people diagnosed with MDD do not actually receive a treatment for their depression. And so we made sure to include a no treatment option in our model. We've also really heard from you and from all of our caregivers and partners that caregiver burden is a huge factor when you're addressing an issue around MDD. We continue to struggle, like we had talked earlier, about finding the right data source to include in the model, and that's part of our questions that we're asking today. The MDD model is a demonstration of IVI's learning approach to health technology assessment. This beta version is not perfect, but we hope that we can work with you to improve the model and improve how we approach health technology assessment. I'm now going to turn it over to Dr. Rick Chapman, IVI's Chief Science Officer, who is going to walk through the demonstration of the model. We will then have time for questions and answers. Thank you guys very much, and I'm going to turn it over to Rick. Thank you.
Thank you, Erica. Before I get into the model itself, I'll just talk a little bit about the background of the model and what type of model it is. But before that, I wanted to just echo Erica's thanks to those who have been working with us throughout this model development process. It really was a team effort and involved a lot of back and forth with various stakeholders. And so we appreciate all of the input and appreciate all of our partners who have helped us develop the model and the data that goes into it. So wanted to start by noting a few key features about the value model. First, this model is a micro-simulation model rather than a traditional population cohort model. And we believe that this will help us better capture the diversity of people's experiences in the model. You can see, if you look at time horizon, that this model is a lifetime model, but we also have the flexibility for users to set interim time points. So they can look at 1 year time horizon, 3 years, 5 years, or go to lifetime. We will just note that the further out you go, based on short-term data, of course, the more uncertainty that will come into the model. Another thing is this model can look at not just individual treatments, but also can look at treatment pathways and go through sequences of treatments and compare those to each other. We can also look at people who have no treatment. As Erica mentioned, that was something we heard was very important from different stakeholders, that a lot of patients, even after being diagnosed, have delays in getting active treatment. So we wanted to be able to model that in here. And as she mentioned already, we have both pharmaceutical and non-pharmaceutical treatments in this model, which is, again, different than a lot of those that are out there. So I think that's the last slide, I believe, Erica.
Hold on 1 second. Yeah, I think there's one more.
Okay.
Oh, no, this is at the end. Yeah, I'm going to stop sharing now and let
so
you.
So now I'm going to share the actual model itself and walk through a demo of the model. If any of you happen to have the model open or want to open it now, you can kind of walk through it at the same time as I am. If you open up the IVI-MDD Value Model webpage on our website, this is where you start. You can see our open public comment period here, and we hope to hear from you all by December 15th. And if you scroll down, you can actually view the model and go right into the model. And this is the welcome screen that you see. There is a registration or sign-in process, and then a welcome screen that briefly describes the model and also points to some additional resources. So there's a model technical report. The R package with the actual model code is available. There's a glossary for terms that people may not be familiar with. And I should say right now that I will try to avoid using jargon and a lot of abbreviations, but if I do slip into some of that and there's something that you don't, term you're not familiar with, please just put that in the Q&A and we'll try to answer that and provide that reference. We also have frequently asked questions about the model and references for some of the inputs that go into the model. As Erica mentioned, this is a beta version of the model, so we know it's not perfect right now, but we thought it was important to get the model out there and get your input so that we could refine the model going forward. And what we're hoping to hear is around the structure of the model, around data inputs, and around some of the assumptions that are in the model, as well as is the user interface useful and friendly. Also, if you have any questions, as Erica mentioned, please put them in the Q&A. We will have time for questions at the end, but if something urgent comes up along the way, don't hesitate to put that in. So once you get to the opening page and click through to continue, it takes you to the Model Analysis Manager. And this is where there are a couple of preloaded analyses that we've put in as sort of base cases, one that is comparing individual treatments and one that's comparing treatment pathways. We'll take a look at that treatment pathway comparison as an example of how to use the model. But you can also see there's a place here where you can create new analyses. And so as you start to use the model, you can do your own analyses, save those, come back to them later, and modify those or run additional analyses for comparison with each other. And we'll show some of that capability as we go along. So if you look here, this is the base case treatment pathway comparison that is preloaded into the model. You could see if you had created additional analyses, they would be here under My Analyses. And from here, you can also create a new analysis. If you look at the bar across the top, this kind of leads us through the model, setting up the model, and then some of the outcomes that come out of it. In this particular case, we've got the preloaded inputs here summarized. The treatment inputs, you can see, can be pathways that we've entered here. We've got here no active treatment. And for this particular demonstration, I'll be concentrating on just the first two paths here. But you can see you can put up to 5 treatment pathways and up to 4 lines of treatment in each pathway. And if you go to all the way to the 4th line, there's also an option to put in brain stimulation therapy. In this particular case, we're using RTMS as the example for brain stimulation therapy. So as I mentioned, we'll be looking here at the first 2 pathways, no active treatment, and comparing that with 4 lines of treatment with various SSRIs. And so this is a patient starts on SSRI first line, doesn't get complete response, so moves on to a second line SSRI, eventually moves on to a 3rd SSRI, and then finally a 4th. So really cycling through different SSRIs. The reason we use this example is when we did a claims analysis in the Carelon commercial claims database, we actually found that this was by far the most common treatment pattern among patients who were newly diagnosed with MDD. Along with the pathways here, you can also look at the efficacy, the complete response rate and partial response rate for each of the treatments. Adverse events are in here. Right now, we have sort of a single severe adverse event that's applied to the different types of therapy. Importantly, you can also put in placeholder adverse events. If there's certain ones that you would like to model, you can put in the percentages here. And I should have mentioned earlier, along with the treatments that are currently in there, there is the option for users to put in a placeholder therapy. So if there's a new treatment or a hypothetical treatment that you'd like to model, you can put in the data here for that and see how it compares to other treatments that are already on the market. And finally, disutilities for the severe AE, those can also be changed. And for any of these, though, the way to change those is to use this edit button, which will take you to a screen where you can change any of these inputs. You can also look at population characteristics, age, race and ethnicity, or sex, and these are editable. Right now, the race ethnicity category is grayed out, but we will have that functional in the final version of the model. For economic inputs, there's several different things that can be changed here. Here you see the cost for the treatments. This is treatment cost per month, and then the brain stimulation therapy is assumed to be a one-time cost at the 4th line of therapy. You can, currently we don't have lab and monitoring costs in here because they're relatively minimal for these, but you can certainly go in and edit that and add those in. There's also transportation cost, the cost of going to doctor's visits or to pick up treatments or receive treatment. Healthcare utilization cost, which will be put in. Productivity loss. So we look at, from a societal or an employer perspective, it may be important to think about productivity loss. So that's also an option to include in the model. You can see here that we break productivity down into both absenteeism and presenteeism, where absenteeism is the missing work because of your illness, and presenteeism is you're actually able to attend work, but you're not able to work at full capacity because of your illness. And finally, caregiver family member cost is also something that users can add to the model. Right now, we don't have those costs in the model because we're looking for fit for purpose data to use for that. And so again, that's one of the things we'd like to hear in the public comments is if anyone has data sources for those types of costs, we'd love to hear about those. And then finally, if you look at the last box over here, we have quality of life. You can see the current utility values or quality of life values that are being used for first and second line therapy. There's a decrement for third and fourth line therapy, which many people think of as treatment-resistant depression. These values are from the literature, but again, these are things that are editable. And so if you have your own values or your own guesses about what these values should be, you can put those in and see how it changes the model. You can also change the time frame for the model. So here you can see right now it's a 5-year time frame and 3% discount rate for cost and outcomes. So that's how you set up the model. You can see these are the default values we have in the model right now. And then once the model has all of these inputs in, you run the model, the output comes out. We're going to use this pre-run example so that you all don't have to wait as the model runs in the background. And then you can look at the outcomes that come from the model. So here we see clinical outcomes from this run. And as I said, we'll mostly focus on these first two pathways here. Just a reminder, the pathway 1 is no treatment, and pathway 2 is cycling through various SSRIs for 4 lines of treatment. And you can see, as expected, if you have no treatment, you're much less likely to ever reach remission than if you have the SSRIs. I should mention, if you hover over these pathways, you can actually see what's being modeled here in terms of treatments. You can also look at other outcomes. There are many outcomes you can look at here, not just percent in remission, number of complete responses. Again, you get more responses with active treatment than with no treatment. Number of complete responses. You can also look at number of responses, both complete and partial. Number of remissions, relapses. Months to the first complete response, and you can see here there's a very dramatic difference. It takes over 2 years on average to get a complete response with no treatment. This is kind of a spontaneous response for certain patients, whereas it takes around 6 months for the patients on average who are cycling through the SSRIs. This is months to first complete response. You can also look at months to first response, whether complete or partial. The amount of time that patients spend on average in complete response. Again, you can see here, as expected, it's much higher in patients who are receiving active treatment than in those who don't receive treatment. And finally, you can also look at life years or quality adjusted life years. And here you see that active treatment makes a real difference in terms of quality of life over the 5-year time period. Along with these charts, you can also look at all of these outcomes in one screen by choosing the table option over here, which, as you can see, shows all of the responses in a tabular format. If we go to the cost screen, you can see a similar setup with the chart, or you could look at it in tabular format. Here in the chart, you can see the total costs are higher for patients with no active treatment versus those with active treatment. Here, you can see that's because if you look at direct treatment cost, even though there is treatment cost for SSRIs, but there's no treatment cost for the no treatment, of course, that treatment cost is relatively low, and it leads to avoided other healthcare costs, such as emergency room visits or hospitalizations, and also leads to less productivity loss. And so in total, you end up with higher cost for no treatment than if you're doing active treatment because of some of the cost offsets that are associated with that. You can also toggle on and off certain costs. So you can see, if you just wanted to look at direct healthcare cost, for example, you could take out the transportation cost and the productivity cost and just look at healthcare costs. So here we're just looking at these first two categories. So there's a fair amount of flexibility there in terms of how we can look at cost. Then if you move on to the cost per outcome screen, you can see here we're taking the first two output from the first two screens and combining those. And so we're basically saying, okay, pathway one has a certain associated cost and certain outcomes that are associated with that. If we take the cost and divide it by the number of outcomes in terms of effectiveness, what do we see? And so here you can see this is the cost per complete response. So really saying the total cost over 5 years divided by the number of complete responses we get over those 5 years. And again, you can see, as you would expect from what we saw on the outcomes screen and the cost screen, it's much higher cost per complete response for no treatment than for the treatment using SSRIs. This is because you have a higher cost here, but mainly driven by the higher number of complete responses that you get with treatment versus no treatment. You can also look at cost per remission, cost per life year, or cost per quality. But you can see there's really multiple ways of looking at cost effectiveness here and thinking about these different treatments and how to compare them. Again, we also have the option to go to a tabular output here. So this is all fine, but you may remember that I mentioned there's uncertainty as you go further out in the model, or even for relatively short time horizons, there may be uncertainty around a lot of these parameters. So you may want to know how much stock can I put in these results. And so we do have a sensitivity analysis screen. In this screen, you can look at the top 10 input drivers of a pathway. So you can select which pathway you want to look at, and you can select which outcome you want to look at. Right now, active in the model are qualities, net monetary benefit, or total cost. And so you can look at what's really, which variables in the model, if you change the values of those, will influence the output the most. And so you can see there are several variables here that really have no influence on this particular outcome. Some of those you can think, for example, if you're looking at qualities, a cost variable is not going to have any influence on that. Conversely, if you're looking at cost, changes in utility value are not going to have much of an influence. Here, where we're looking at quality adjusted life years, the quality of life or utility value is, as expected, going to have a big impact on what those results look like. And you can see here that they do vary across the range here. So there's various different ways to show this. Right now, what we're doing is a tornado diagram, which has the most influential parameters at the top of the chart, and then the least influential as you go down. We would be interested in hearing from users about other ways to present this data. Right now, we're showing one pathway. We would be interested to know, would people be more interested in seeing the incremental results between two different pathways, and how the sensitivity analyses may change based on changing parameters, or looking at that kind of a comparison. We'd also be interested to know if there are other outcomes you would like to see in the sensitivity analyses. And even though the tornado diagram we think is a relatively intuitive way to present this, are there other types of presentations of this particular data that you'd like to see? And then finally, we have clinical cost effectiveness, and this is really taking what we know about the cost effectiveness of each of the treatment pathways relative to each other, and plots them on what's called an efficiency frontier. And so I'll spend a little time on this screen, because for those who aren't familiar with cost effectiveness analysis, it takes and even those who are, it takes a little bit of time to grok this. So here what we do is we take each of the pathways. Here we're looking at all 5 of the pathways that were put into the model, and you sort by cost and qualities, and really look for what's the lowest cost, the lowest qualities, What's next highest, here you can see we're gaining a little bit of qualities, 0.846 for a small cost, $2,300. And so you end up, when you divide the incremental qualities by the incremental cost, the difference between these two, you get the incremental cost effectiveness ratio, which in this case, it comes out around $28,000. So relatively cheap cost for the gain in qualities that we're getting. Then if you look at the next highest pathway, you can see here, again, we're getting a gain in qualities, a little smaller than what we got before. And the cost is much higher than what we had to have before, the incremental cost between these two to gain that amount of qualities. And so when you divide that, you end up with a very high cost effectiveness ratio. I should point out, this is a beta version of the model, and this is a demo of the model. So don't take any of these numbers as final numbers that should be put into a publication or anything like that. And then finally, you see in pathway 1 and pathway 4, pathway 1, you're actually spending more money in total and getting fewer qualities. This is the no treatment pathway again. So we aren't offsetting any of the hospitalizations or emergency room visits, and we're not getting the quality of life gains that we'd get from treatment. And so this is what we would call a dominated treatment, in that you would never pick this because it's going to cost you more money than these two and give you fewer qualities. So you're really spending money to get less. And you can see there is another example of this here with pathway 4. This is also shown on the chart here to the right, where we've mapped out the effectiveness over 5 years in terms of qualities, and the y-axis with the 5-year cost in dollars. And you can plot each of these here in terms of the cost and qualities. So you see here pathway 3 with $77,000 and 2.88 qualities. So you're getting a fair amount of qualities, but a little bit of a higher price than you are with these two. So if you plot these out like this, you can see here are the treatments or pathways that are on the efficiency frontier, in that they're non-dominated. And you can actually see, if you imagine a line going from this pathway 2 to this pathway here, pathway 5, it would be a relatively flat line, which reflects the lower cost effectiveness. On the other hand, going from pathway 5 to pathway 3, if you drew a line here, it would be relatively steep, reflecting the high cost effectiveness for that particular comparison. And finally, you see pathway 1 and pathway 4, which were our two dominated treatment pathways, are on the inside of this curve. And that reflects that they're not efficient choices, or wouldn't be efficient choices of our money. So those are the main screens that you walk through as you do an analysis. As I said, you can start with one of the preloaded analyses, the base case analyses that are here, and start with the default values that are here and edit these. You can also go through and create a new analysis, which brings up the treatments and treatment pathways would all be blank, and you get to pick and choose which treatments or treatment pathways you would like to compare. And we just take you through to that. You can see here, this does have default settings in it in terms of population, some of the inputs in terms of efficacy, but in terms of treatment selection, you get to choose up to 5 treatment strategies if you want to look at individual treatments. And you can see the selections here. We have no active treatment, SSRI, SNRI, atypical antidepressants. This is the placeholder treatment that I mentioned before if you want to bring in your own data. There's psychotherapy, and then combination treatments of SSRI plus psychotherapy, SNRI plus psychotherapy, and atypical antidepressants and psychotherapy. You can also go to the treatment pathways and select from the same treatments along here, but here you can create not just a single treatment, but look at several lines of treatment. So if I put in an active treatment here, you can see that I can select line 2, line 3, line 4. And if I select a line 4, I can also select the brain stimulation therapy as an add-on at 4th line. You can also go into the clinical inputs and make changes here. You can see because I only chose SSRI, that's the only option that's showing here. And the same thing for cost. General settings is where you can change the time horizon, 1, 3, 5 years, or lifetime. This is another area we'd like to get feedback. Are there other options that people would like to see here? And there's also the ability to change the discount rate and do differential discount rates for cost and effects. So with that, I'll pause and see if we have any questions. I will mention also really quickly that along with this user interface and as a way to interact with the model, you can also go to our GitHub site, which has the actual R code here for the MDD model along with our prior models. And so if you really want to get into the programming and really want to get under the hood and see how the model works, or make some changes that are more extensive than what you can do in the user interface I just showed, this is where you can go and download the R code and change it however you'd like. So that concludes our demo through the model, and I'll open it up now to questions.
So I wanted to introduce myself really quick. I'm Lara Jimrains, and I'll be the moderator for our Q&A session. And so as Erica mentioned in the beginning, if you guys have any questions regarding the model or what Rick just went over, please feel free to put it in the chat. But before we begin answering some of the questions, I wanted to start off by mentioning 4 areas of feedback that we're really looking for in regards to the model. And so the first one would be the model design, and that includes the structure, key assumptions made, and input sources. So for example, the internal structure and sources for the model. Another area is the extent to which the user interface, which is the front-facing design of the model, is user-friendly and effective in addressing your decision needs. Third would be suggested approaches to address some of the data gaps identified in the MDD model. For example, databases or research partners we should consider. And lastly, any additional methodological questions or real-world applications that IVI should prioritize following the launch of the model. So those are our 4 areas, like I said, of feedback that we would really like to see from our audience today. I also want to mention that if any of your questions do not get answered during the Q&A, please also feel free to reach out to our info email address, which is info@thevalueinitiative.org, and we'll be able to answer some of your questions there as well. So one question coming in for you, Rick, specific to the model is, can you clarify the health utilities and whether they reflect EQ5D or something different?
Yeah, the health utilities do come from the literature. As I recall, it was 2 different sources in the literature, one for major depression overall and one for treatment-resistant depression. I can't recall right now exactly how those utility values were collected and whether it was the EQ5D. We do have our modeling team from Medicus here who helped us build the model, and so I just wanted to check and see if they happen to recall what the instrument was used to collect those utility values.
Hi, Rick. Yeah, I can answer that. Yeah, they were from a review of reviews, as it were, and we did take the kind of solution sort of estimates or means from that study. I would say about 80 to 85% of all the studies within that review were EQ5D. EQ5D has been the kind of primary tool for calculating utilities for the vast majority of health state utility values for cost effectiveness models over the last 20 or 30 years. There is a fairly strong and growing literature on the limitations of EQ5D as a generic measure. And there is a growing literature on the limitations of the kind of some of the background sort of assumptions around health state utility values. And that is shown a little bit in the review documents that, the mean levels that we use, the variety in this review, which I think looked at 30 something different studies that tried to estimate EQ5D or other based health state utilities for non-response, complete response, and partial response. And there was quite a lot of variation. Probably the biggest variation is non-response, which kind of can range from something as low as 0.2 to something as high as 0.6. So the fact of the variance suggests that EQ5D is not a great measure in this instance. We've kind of adhered to what traditionally has been used, but I know that IVI and Rick and Erica and all the team are working closely with PAVE to try to work forward and improve and sort of develop better techniques for quantifying quality of life in MDD patients. But as a holding pattern, we're sticking with the kind of traditional methods and sources that we have from previous models and previous exercises. But I certainly understand the kind of caution around that, and I think IVI is working to look at better ways of addressing that.
Yeah, and thanks, Warren. And I think you also saw that when we looked at the sensitivity analysis, that those utility values were big drivers, certainly of the qualities. And so it is important to think about what goes into those. It's always something that we struggle with, is do we have the right utility values from the right population that matches what's in the model. And that's also, some of those kinds of caveats or limitations around that are also why we include all of those other outcomes in the model too, so that you're not stuck with looking at the quality.
Great. So the next question we have is, what's the time between each line for a given pathway? The default total time frame is 5 years. So does that mean the model evenly divides the 5-year time frame between each line?
Yeah. So 5 years is what we happen to use in this particular example, but you could use different time frames, of course, up to lifetime. It does not evenly divide the 5-year time frame between each line. Basically, patients start on a treatment in an initiation phase and have a certain amount of time to have a response. And if they have a complete response, they stay on that treatment until they don't. And if they have a partial response, we give them additional time on that treatment to see if they reach complete response. If they don't reach complete response over one of those two time frames, then we say that they're discontinue that treatment and go on to the next line of treatment. Any nuances you'd like to add there, Warren?
No, I think that sums it up pretty well. I mean, just to answer the question of the time relating to the 5 years, the function of the time to relapse in the model, and this is one of the benefits of the simulation model, as Rick said earlier, over the Markov model, is that it's a function of a lot of downstream effects. So depending on what drug you get and what sort of certain characteristics of you as a patient, or whether you've had a treatment before and things like that, that will kind of determine the average time that you'll be successfully on that treatment before you relapse or discontinue or whatever. So it's a function of those early components that result in the kind of downstream effects. And with a lot of pathways, you'll often circle through the 4 different lines of therapy before you get to the 5 years. Not in all of them, but in probably most. So the 5-year timeline is quite a good way to capture quite a lot of the kind of fluidity and variance within the pathways. But yeah, the key thing is that the time to relapse is a function of a lot of components that happen at the point at which your choice of therapy or the type of person you are, or characteristics of the patient, or whether you've had lots of therapies before and what you've had and things like that. So the simulation allows us to kind of try and link that to a slightly more realistic way in which relapse really happens, as compared to some of the older form of models that everyone kind of got the same number at each time period.
Sorry, Alice Kate from Medicus here, just adding on to that, putting in a plug for the technical report is one of the documents that's in the GitHub, I think, and it has some diagrams that show they're similar process maps that kind of show the pathways that a patient can take and how, you know, they might go from one line of therapy to another.
Yeah, goes into a lot of detail on that. And that technical report can be reached from the main user interface screen.
Great, thank you guys. Next question is, what is the role of the patient characteristics? How fully is this heterogeneity propagated?
Yeah, that's a very good question. Not as fully as we would like it to be is the short answer to that. And that's largely due to lack of good data that's stratified by these different patient characteristics. And so that is something we would love to do in future versions of the model, is find better data sources that would allow us to include more of that heterogeneity for these populations and have more impact on what happens in the model.
Great, thank you. Our next question is, how is caregiver burden included? It's not listed as a cost item.
So there is the ability to put in caregiver burden. We don't currently have any cost or burden associated with that right now because we're still looking for good sources. We have found some data out there, but it's not quite broken down in the way we would need it to fit with the health states that are in the model. And so, again, this is one of the things we'd love to get in the public comment period, are ideas for either data that's out there or where we might go to be able to generate that data and have it for use in the model.
Great. Another question is, do the mean time to different outcome measures account for censoring? For example, in a 1 year or even 5-year time horizon, is it possible a majority of individuals will not experience that endpoint and might not for a long time?
Warren, do you want to take this one?
Yeah, I mean, it does in that way. I think most of the outcomes that occur, as I say, when we run the 5-year model, the vast majority of patients do run through within 5 years. Obviously, in lifetime, everything gets accrued. But that data isn't censored per se. You know, in theory, we'd only really need to censor if we had, you know, multiple populations. So most of the outcomes that occur within the first 5 years are kind of included in the 5-year run. So there's no real need for censoring.
Great.
Thanks.
Another question is, why is the race category currently grayed out?
Before we get to that, I saw AK come off mute on the last question. Is there something you wanted to add?
Oh yeah, sorry. I was just going to add, I think that some of those time to event outcomes are conditional averages anyway. I think Warren's right that for the most part, you know, patients do sort of have enough time. 5 years is enough time for them to achieve the different endpoints that we're looking at. But I think that we do calculate conditional averages. So for example, time to remission conditional on ever achieving remission.
Yeah, so it takes those zeros out for that particular calculation. Yeah. Thanks. And then you'd asked about why race and ethnicity are currently grayed out. That was something we wanted to have more time to think about how to implement in the model and to get more feedback from users about how it should be implemented in the model. Again, you know, this goes back to the question about heterogeneity and how fully it is propagated through the model. You know, we know there are correlations between race and ethnicity and other aspects of MDD treatment, but we don't have complete data on what those relationships are. And so we're concerned that including those without accounting for those correlations could lead to spurious or misleading results. Again, we're exploring potential data sources and would love to get your feedback on that.
Yeah, I 100% agree. I mean, a good example that we discussed before is that one of the things we've got really good data on is mortality, and we have it by broken down in lots of different stratifications. And some other aspects like treatment gaps and relative efficacy and time spent on particular treatments, etc. We don't necessarily have that data in that quite way. And if you just put in, or you just utilize the data that you have, it can actually give you rather bizarre results. You know, if we just have mortality data for a particular race or ethnicity, and they happen to is a group of people who live a little bit less long than another group, it will make it look like the value of the treatments are slightly lower, but it's an artificial artifact because you're then assuming all the relative benefits of all the other aspects are the same. And so all you're doing is you're just modeling relative differences in mortality and ignoring everything else. So it is difficult and dangerous to run a model with only partial data for certain characteristics. And I think Rick's absolutely right. I think it's better for us to get it correct and apply it universally than to apply it piecemeal and then risk peculiar or bizarro results that get people's heads spinning.
Yeah, I think it really points out the importance, two things, the importance of subgroup analyses, but also the importance of being very thoughtful when we do those subgroup analyses so that we put them in the right context and interpret them in the right way.
Another question we have is, how does absenteeism work? Is it a sporadic thing like missing some work days in times of crisis, or more like leaving the workforce temporarily or permanently?
Yeah, another good question. So for most of the times of the way these are collected is they ask people to think back over a week or some period in the past and estimate how much time they've either missed work or been present at work, but not at 100%. And then those are extrapolated to longer time periods. So those would capture work days that were in times of crisis. And would capture in some ways the leaving the workforce, temporarily, certainly. One of the things that I think cost effectiveness analysis or these types of models struggle with is there are people who leave the workforce permanently. There are also people who maybe make different career choices because of their conditions that they're dealing with. And so that's just sort of taken as a given. I think that people are there wherever they are, but we don't necessarily capture in these types of models that sort of long-term or broader impact of how it may change your choices around career or education in that way. And again, I think that's something that has to be captured in a more contextual, broader look at models. It's certainly something that if you had the data long-term enough and put it into the model and ran it long-term, you could model that people moving out of the workforce and the consequences in terms of productivity. But again, you would need that kind of long-term data to be able to do that.
Yeah, it's very much like we were talking a little bit earlier about the relapse functions in terms of understanding when relapse is likely to occur and the relative risk of it happening at each time period as a function of some early characteristic data, be it treatment type or treatment efficacy or whatever it happens to be. Similar sort of function could be put in play for that sort of data, understanding the relationship between how long someone has been depressed or what line of therapy they're on and the relative risk of that person. And it's simply, at the moment, the only thing that's stopping us doing that is the availability of the data. As Rick says, most of the presenteeism and absenteeism data are just kind of big old chunks of average. And they're taking 20 people who've given up work for good, and they're taking another 20 people who had a week off. And the average is 18.3 weeks or something. Do you know what I mean? So at the moment, we're moving away from just kind of static mean sort of data points and towards kind of functional relationships is the way forward for kind of better understanding or translating of the data we have into a functioning model that is more representative of reality. But a bit of our kind of holding point at the moment is being able to find data that has that sort of relationship background to it, rather than just kind of lots and lots of sort of tables and rows and columns of data, which tends to be the way a lot of the data is collected, sadly.
Thanks.
Just to add, just to give a very brief sort of description of how the things like absenteeism costs are currently being calculated in the model. Absenteeism and presenteeism costs are not stochastic. They're just applied, we say, by age groups. We have an average employment rate and an average, percent of time that is, where patient experiences absenteeism or presenteeism. A better state-based. So if you're in the non-responder or complete responder.
Your sound is cutting out a little bit. AK.
Oh, I thought I was going to work today, but yeah. So they're just, we have average employment rates and average absenteeism rates, and we multiply those to get sort of percentage of time on average that patients are experiencing absenteeism, and that's how absenteeism costs are calculated in the current version of the model.
Great, thanks.
Well, I think that's all we have for questions today. Thank you, Rick and the Medicus folks, for answering our questions in our Q&A session today. Again, if anybody has any additional questions, please reach out to us at info@thevalueinitiative.org, and we'll get back to you guys.
So as Erica mentioned, now we'll go into a section of the webinar. It's really a chance to ask the programmers, the modelers, about some of the choices they made. And so if there's any really detailed or digging deep questions you want to ask, now would be the time to do that. And again, please use the Q&A. I had one question I wanted to start with that I think people might be wondering about is, we mentioned early on that this is individual patient level simulation. And in fact, I think technically we're calling this a continuous time individual patient simulation model, which is quite a mouthful. But, most models, it seems, in MDD that have been developed prior and actually outside of MDD, most models are built as cohort models, a Markov cohort or some variation of that, semi-Markov. And so just wondered if you could talk a little bit about why we chose to use this particular structure for the model as opposed to something you might see more traditionally.
Yeah, sure. I mean, it is a good question. As you say, traditionally, Markov models, health state transition models, as they're sometimes called, which is a long way of saying something very simple, are the more common methodology that they have been used more often. But I think that's changing. If you look at the last 20 years, 90% of models would have been kind of Markov or semi-Markov. But probably in the last year or so, probably half have been simulation models. As our computers get a bit stronger and we have more and more kind of types of code and different ways to build these models, and also as audiences become more familiar with these sorts of programming and these sorts of models, I think they do become more accepted. I think people have learned over time that Markov models or health state transition models can be a bit clunky. They do rely on us viewing diseases in a quite simplistic way, and that we talked about sort of time-related factors, how something that happens early on can have a big impact on something that happens later on. Well, those health state transition models are usually historyless, i.e. that the rate at which someone transitions between states can be the same at month 1 as it can be at month 12 or something, which of course is, we all know, and all the clinicians and patients probably know, that's not really very realistic. So simulation models allow us to do some things that maybe Markov models don't do, or health state transmission models don't do. And they allow us to kind of ask questions in a slightly more detailed way, and be a little bit more flexible. But I think the big thing, and I think you alluded to it earlier, is individual patient simulation models allow us to look at heterogeneity. MDD is a horribly complex disease. It can be episodic, chronic. Someone can have many episodes over a short period of time and a small number of episodes over a long period of time, be in remission for many years, be in remission for 5 minutes. And all of those can be, the way in which they respond to different treatments can be very different depending on their context, and we're talking about socioeconomic status and race and whatever, but also like the type of delivery mechanism, a primary healthcare doctor, or they get, prescribed in ER settings or by a psychiatrist. We know that there is as much variance in terms of how that affects as just in terms of the variance within the treatment alone. And we don't address all of these things in our model right now, but the individual patient simulation model allows us to be able to do that as and when the data becomes available, or as and when we are able to make or choose to make certain assumptions about how those relationships happen. So it really is about getting a little bit closer to reality and trying to address heterogeneity.
Thanks, Warren. So it really, the advantage is flexibility and the ability to model the real variation in the world more in the model. I guess the disadvantage is it's more data hungry and requires a lot more.
No, that's absolutely true. Yeah, I said all the kind of nice things about it, and I forgot to mention that there's always a trade-off, and the trade-off is you need more data, and the data needs to be connected to X and to Y rather than just being tables and columns. But we'll keep plugging away, and I think it's worth the challenge to get closer to reality, because I think oversimplistic models can be damaging because they paint inconvenient or convenient but not particularly truthful stories.
Yeah, I think that's a major point, and one of the reasons why we wanted to have it built this way is we know that heterogeneity is there, and just because we haven't measured it or don't have good data for it, we shouldn't pretend that it's not there and just look at averages. This helps to point out where there are data gaps, and I think that's one of the things we should emphasize is that what we're trying to do with these models is not just come up with an answer for a particular research question, treatment A versus treatment B, but really point out how far can you go with what we know now, and where we really have to point out that there's still a lot of uncertainty or a lot of data that we don't have that we'd like to. Another question that often comes up whenever we do models is around adherence. Did you include adherence and persistence in the model? And so I just wondered if you could address that.
Yeah, AK, you might be better qualified to answer this one. So I know you spent a lot of time on thinking through this question.
Sorry, full disclosure, I was typing a response to in the chat. Can you repeat the question?
We were talking about adherence and persistence and how we can factor it into the model.
Yeah, so I think the reason that it's not explicitly sort of a separate kind of where you can specify a discontinuation rate, for example, is because all of the values that we have from the clinical trials and the STAR-D, which is this big naturalistic study where we get some of our relapse information or relapse rates from, already kind of incorporate discontinuation, right? So for percent of patients who are responders or complete responders, partial responders, things like that, it accounts for the fact that some people may not have adhered fully or been completely compliant when they were receiving treatment. And so if we sort of added that on top, in addition to using the sort of efficacy rates that we get from those studies, then it would be like double counting, right? So that's sort of the reason why we decided not to include them explicitly.
The adherence is kind of baked in already. Yeah. And then I'm going to ask one final question, and then I'll just put in a plug. If anybody has any additional questions, this is your chance to put them in the Q&A. One of the things I didn't really point it out, but one of the things in the model is that as we go to higher lines of therapy, the model assumes lower efficacy for those later lines of therapy. I wonder if you could just say a little bit about why that was important to put in, and what the rationale for that is.
Yeah, I mean, there's two main reasons for this. I mean, it's like a lot of the questions. Part of it is logic, and part of it is holes in the data. But I think there's probably two main reasons for it. Firstly, there aren't sort of multiple line of therapy effectiveness data for all the different types of interventions that we have. And so, some of the older ADTs, there is quite good data on how efficacy tends to fall away over time. But for lots of others, there isn't so much. So for some of it, we are able to put in kind of good data. We can say, efficacy falls 20% each line of therapy and then kind of plateaus out at kind of 3 or 4 or something like that, because we've got good data on it. But other stuff, there's not so much. So we have to make a choice, with all these models where you've got kind of data lacking. And we have this, if we only assume that decrement applies to treatments for which there are data, it's the old missingness paradox, in the sense that the better data you have, the worse you make an option look, because you have all the data that critiques or kind of subsidizes it. So it ended up applying sort of sets of decremental impact to having failed a therapy once across all interventions to offer kind of something of a fair comparison. I think the second reason that there's also a lot of anecdotal evidence that patients who are less treatment naive or have experienced more rounds of various types of treatment, even the ones we don't have data on, do tend to have smaller times of relapse, for example, other types of outcomes. So even though there isn't data per se on absolute rates of change in terms of CR, PR, for example, which are the main 2 outcomes, the way the other data implies or suggests that it's an genuine effect within those other lines of therapy is, can underline an assumption or a choice that we make in terms of the structure of the model. So there's, of course, a lot of other data as well, as we know, like half-life of treatment efficacy stuff in many other diseases. So there's a logic to it that we've seen elsewhere, and sometimes we have to bring partial information to play to try and keep a logic, and comes back to this thing we were talking about, pulling in the race data. We can't pull the race data in for just one thing, because then we're painting an incomplete picture, and it isn't very helpful. If we've got lots of data for one thing and not so much data for another thing, we've got to make a more logical, reasonable choice. We can't just put in the data we have and ignore the data we don't. So we don't apply that decrement in that way. We kind of, we make a logical choice and use an assumption based on the best data we have available, and try and apply it equitably.
Thanks. And these questions I've been asking, part of the motivation of this is these are areas where we would like to get feedback on some of the assumptions we made. So if anybody has any thoughts on that, we'd love to hear that. We did get a couple of questions in. One is, have we attempted to validate the model, and in particular around predictive accuracy?
Yeah, I mean, we've done some sort of internal evaluation. We've got sort of internal and external validation. Internal validation, obviously, we can run scenarios where based on kind of previous data and historical data, we expect to see certain orders of magnitude. Like, we expect this to be 3 times as good as that, or we expect this to be number 1, this to be number 2. We can, based on historical data. So when you're kind of trying to predict what's going to happen, you can go back and look at what has happened in similar situations before. But that's quite limited, obviously, because there aren't a lot of studies that have necessarily tried to answer the exact same question as our model is producing. So we can do a little bit of that internal validation. But then there's external validation, which is, much more complete attempt to kind of run those scenarios and then test it against kind of realistic sort of real world data in exactly the same way. That has been more difficult because there haven't really been a lot of models. Like, we've tried to build, one of our challenges was to build a model that maybe overcomes a lot of the limitations, a lot of the previous models. So inevitably, oftentimes we've compared it, we've run a particular scenario that we can get close to comparing with an older model. But because of its relative simplicity, oftentimes, oh, well, this doesn't give us the same answer, but is that because our model's wrong, or it's because we're asking a different question? So it's quite difficult. We've done a little bit, and it would be nice to do more. And I think there's also analogous validation, which is having lots of people use it, run scenarios, and see if a lot of those scenarios sniff the pass test. No, pass the sniff test, which we hope to get from people, to feedback to us. But yeah, when you're trying to do something a little bit different, and maybe something for the first time, it is a little bit difficult to do some validation. But AK, I know you've had some thoughts on validation, and you ran a lot of the scenarios. Did you have anything to add?
Honestly, no, I think you nailed it. I think predictive accuracy, I'm not sure is particularly relevant here, because it's not like it's a regression model where we can sort of split a sample and, and have our test and our validation sample and things like that. And we're working with purely hypothetical patients. But so what we'd like to do is just sort of run the model with a scenario that we see classically, like the SSRI for all 4 lines of therapy, like Rick was talking about earlier, and just try to compare that to data that we have for that type of treatment sequence that's in the literature. And like Warren said, we've done that to the best of our ability with what we have, but unfortunately, there's not a ton of options, external benchmarks for us right now. But so again, if there's another plug, if you have any studies that you know of that we may not have come across, please, by all means, let us know.
Yep. So comparing it to historical data is mainly what we've done so to this point. We have one final question, and it's kind of going to put you on the spot, but we'll try it. It says, suppose you're writing up the discussion section. What do you think? And this goes back to what you were mentioning before about limitations, Warren. What do you think are the 3 biggest strengths of this model? And what do you think are the 3 biggest weaknesses? And I've got some things I could throw out, but I wanted to give you a chance to tackle.
Yeah, it's a good question. I think there are, if I had to pick 3 strengths, I think it's the ability of the simulation model to address heterogeneity as a point of, it's already kind of addressing a little bit of heterogeneity, but when the data becomes available, or as I know we're in the process of kind of incorporating more data and collecting more data, but that will be, I think, really important. And then I know at the moment, the R version that you can download on GitHub, you can run lots of different heterogeneous. The version, the user interface, the kind of slightly more simple one, it's a little bit more difficult to do because of sort of data challenges. And of course, it would make it hugely complex. So I think that, the ability to address heterogeneity is important. I think moving forward, potentially the ability to ask more real world kind of policy questions. Cost effectiveness models were largely designed to say, and I think you mentioned this earlier, Rick, is treatment A compared to treatment B? Well, that's a very, very narrow position of understanding a policy question or a healthcare question or the evaluation. Lots of literature has shown us that actually who delivers the intervention, when it's delivered, how it's delivered, all these sorts of things show as much variation. Like if you get one of the best psychiatrists or one of the worst psychiatrists, you see the kind of variance in terms of, see it in surgery, psychiatry, lots and lots of different aspects of healthcare. So being able to answer questions, what is the best time to intervene? How important is it to delay? How important is it, not to delay? Think like that, questions like that, more kind of real world questions to be tied into just this kind of very artificial treatment A versus treatment B. I think that has the potential of doing this sort of stuff. And the third thing I think, for me, one of the biggest limitations of traditional modeling is the qualia, and is the EQ5D, and it is the limitation of the assumed utility, linear utility function, and these sorts of things. I love the idea that you guys are working with PAVE, and that we could potentially have, certainly in the MCDA part, and maybe even back in this part as well, the model, the ability to shift away from the kind of shackles of the EQ5D, the qualia as is in terms of the linear utility function, things like that. I think that is potentially a huge plus as well. Limitations, lots of it. We would like to have more functional relationships in the model. There's still, I've talked about, us moving away from rows and columns and moving towards functions. And we've done that a little bit, and we've got 3 or 4 components, but there are 50 moving parts to this model. And most of them are still kind of pretty, rows and columns and means from a study and things like that, which is a shame. It would be nicer to have data sets that we can answer those sort of functional relationship questions. So, data is a shame. I guess, a strength of that I mentioned, about potentially working with PAVE to improve outcomes. A limitation at the moment is that we are, really limited to the lit-based EQ5D quality stuff as well. So that's another limitation. I'm going to ask AK for a third limitation, because it's probably some methodological thing I'm not thinking about, and I haven't put her on the spot for a while. So no, she's refusing to take the bait.
Yeah. Oh man, I mean, you could answer the questions less well, and then it would make it easier for me.
I'm doing my best.
Yeah, I think the data limitations are just the biggest, because I think that also limits the model structurally, right? We're not going to develop a model with all the structural nuance if we don't have the data to support it. Some of that we've done, kind of anticipating realistic expectations for data that we might be able to get in the future. But, you know, there are some things that I think it's harder to get. But yeah, I think, you know, the treatment gap data I'm excited about. So that'll be exciting when we can incorporate some more robust data.
That's a good point. Maybe that's the third. The EQ5D and the utility data is a limitation, and the third positive is the treatment gap stuff. As I say, no, lots of previous models have just assumed, again, the kind of move towards reality. Lots of previous models have just assumed if someone stops, the moment they stop their line of therapy 1, they start line of therapy 2. And that's not realistic. And lots of people have told us that. And so having treatment gaps ultimately be function of what line of therapy you're on, how you've received your care, who's received that care from, you know, what your socioeconomic class is, or race or ethnicity, all these sorts of things. We know there's huge variation in treatment gaps depending on all these factors. They're all kind of big drivers of those things. And I think it allows us, comes back to what we were saying earlier, it allows us to potentially ask questions like, is it more valuable to have a drug that keeps people in treatment for a long time, but maybe have a slightly lower efficacy from an RCT? Or is it better to have a treatment that has a slightly higher efficacy, but can't ensure or guarantee the level of durability of the previous treatment? So that's a question that a lot of traditional models don't ask so well, but this could potentially be a model that asks that question quite well.
Thanks, Warren and AK. I'll just add one more strength, I think, of this model is the patient and stakeholder engagement we had throughout the development of the model. We had as we mentioned earlier, 20-member advisory group that worked with us from the very beginning, and that we went to again and again as different questions and assumptions that we wanted to test came up, and that was very helpful throughout. And I think also just that process makes the model that much stronger. Also wanted to mention, thank you, Warren, for putting in the plug for multi-criteria decision analysis. That will be a part of the model that we're going to add on in the upcoming months. So keep an eye out for that. And that's a way to bring in, you know, even broader set of criteria and allow people to weight those according to their own preferences. And so we're looking forward to putting that into the model. So with that, I think that's a good question to end on. Thank you all for attending today. Thank you, the Medicus team, for being a part of this, and the IVI team. Also wanted to just say again, please, I hope this whets your appetite to go and play around with the model, see how the user interface looks, if it makes sense to you, if you find any bugs or things that you wish the model could do that it currently can't. We'd love to hear about that. And you can find details on how to submit public comments on our website where the model is available. So with that, I'll say thank you, and I think we'll close out. Erica, any last points?
No, again, we just want to say thank you to all of you for joining us today. This has been a great discussion, and we could not have done this without everyone. We do want to mention that we have 2 upcoming IVI events. There is a webinar on rare disease on November 29th, which is the culmination of our project. And then we're also doing an in-person symposium on equity and the IRA in Washington, D.C. And both of those are open for registration right now, and we hope you will join us again. Thank you to all of you very much.
Thanks. Bye.